You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we introduce the structured approach used to solve technical problems in information technology. Troubleshooting is more than just trial and error. It's a logical, repeatable process that helps technicians identify and resolve issues in a consistent, professional manner. This episode focuses on the first two steps of that process, identifying the problem and establishing a theory of probable cause. These steps are the foundation for effective problem solving and form the basis of the troubleshooting methodology covered in the ITF Plus exam. Troubleshooting methodology appears in Domain 1 of the ITF Plus exam and is a key skill for both entry-level and experienced technicians. It applies to a wide range of problems, including hardware malfunctions, software glitches, and network outages. The exam may test your ability to follow the process correctly or recognize errors in approach. Scenario-based questions are common, presenting a situation and asking what the technician should do first. Learning the correct order and logic behind each step is essential for exam success and professional readiness. Troubleshooting in IT refers to a logical process used to identify, analyze, and resolve technical problems. It involves a structured sequence of actions that help technicians move from problem detection to successful resolution. The process can be applied to nearly every aspect of computing, from system crashes to slow networks. Whether you're working independently or as part of a support team, following this structure improves consistency and reliability in how issues are addressed. A structured approach to troubleshooting is important because it saves time, reduces error, and improves communication. Without a plan, technicians may skip steps, misinterpret symptoms, or overlook simple solutions. A clear sequence allows the issue to be isolated quickly and prevents wasted effort. It also helps ensure that results are repeatable and can be documented for future reference or handoff. Following the structure shows professionalism and increases efficiency. The first step in the troubleshooting process is identifying the problem. This means understanding exactly what is going wrong and collecting enough information to describe the issue accurately. It involves asking questions, examining systems, and gathering both user feedback and system data. Problem identification is more than just listening to complaints. It includes verifying symptoms, observing behavior, and comparing current conditions with expected functionality. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. There are several methods used to identify a problem. Technicians may begin by interviewing users to gather context about what they were doing when the issue began. System logs and error reports can offer insight into the problem's root. Visual inspection of hardware or reviewing software configurations can also reveal clues. Identifying whether anything changed recently, such as an update or a new device installation, is often the key to understanding the current failure. Asking the right questions helps narrow the scope of the issue. What exactly is not working? When did the problem start? Did anything change just before the issue occurred? Is the problem constant or intermittent? Who is affected, and in what way? These questions guide the data collection phase and help eliminate irrelevant information. They also allow the technician to begin forming a hypothesis about where to look next. Once observations and reports are collected, it's important to document the symptoms clearly. This includes recording error codes, timestamps, system behavior, and environmental conditions. Documentation may also include which components are involved, such as a specific workstation or segment of the network. Organized notes make it easier to share findings with others or revisit the issue later if the initial resolution fails. Documentation begins here and continues throughout the troubleshooting process. The second step is establishing a theory of probable cause. At this stage, the technician begins to form an idea about what might be causing the problem. This theory is based on experience, training, Vendor documentation or logical deduction. It's essential to start with the simplest and most likely explanations, such as loose cables, incorrect settings, or permissions issues, before jumping to complex or rare causes. This method is sometimes called questioning the obvious. Questioning the obvious means not overlooking simple solutions. Power cables, input devices, network connections, and software configurations should all be verified early in the process. Many issues can be resolved by fixing a disconnected cable or changing one setting. By checking these basics first, technicians can avoid spending time chasing complex causes when the answer is right in front of them. It's an approach rooted in humility and efficiency, two essential traits in technical support. Multiple probable causes may exist, especially when dealing with systems that have many components. A single symptom, such as a blank screen, could result from a faulty display cable, a graphics card failure, incorrect resolution settings, or even a disconnected power source. In other cases, environmental issues like power surges, overheating, or user error may contribute to the problem. Keeping an open mind and reviewing all possibilities helps create a complete picture of the issue. Sometimes, despite thorough investigation, a theory is not immediately clear. In those situations, it's helpful to group the problem into broader categories: hardware, software, network, or user. From there, the system can be broken into parts and tested individually. Repeating the error or observing the issue under different conditions can reveal new information. Developing a theory takes time and should be guided by evidence, not assumptions or guesswork. Once a theory is formed, available tools can be used to support or challenge it. Tools include event viewers, diagnostic utilities, configuration checkers, and system monitors. Many operating systems include built-in troubleshooting aids that highlight recent issues or offer guided steps. Running a memory test, checking hard drive status, or viewing application logs can all provide confirmation that the issue matches the suspected cause. These tools help avoid guesswork and add precision to the investigation. Knowledge bases, online documentation, and internal support records also play a crucial role during the theory phase. Technicians often search vendor sites or IT forums to look for symptoms that match what they're seeing. Many problems have been encountered and solved before, and these solutions are documented online. Accessing shared knowledge speeds up the process, especially for newer technicians still building experience. Referring to documentation also reinforces best practices and promotes consistency across the team. It's also important to create a hierarchy of likelihood when analyzing causes. Some issues are far more common than others. For example, a software update causing compatibility problems is more likely than a CPU hardware failure. Working from the most probable cause to the least likely helps prevent wasted time. This approach is efficient and reduces the chances of replacing working parts or adjusting settings that don't need to be touched. Avoiding confirmation bias is another key part of sound troubleshooting. Technicians must remain objective and avoid locking onto a theory just because it seems familiar or convenient. Every theory must be tested and verified before proceeding to the next step. If the evidence does not support the theory, it should be discarded, even if it was based on a prior experience. This willingness to change direction leads to better outcomes and avoids frustration or delay. Technicians must also recognize the difference between user-reported symptoms and what is actually happening. A user might say that a system is frozen, when in reality, the mouse batteries are dead. Someone might claim that a server is offline, when it is actually unreachable due to a local firewall setting. It's essential to investigate firsthand and validate every observation. Trust data and system logs more than subjective descriptions, especially when inconsistencies appear. Throughout the identification and theory phases, detailed documentation should be maintained. This includes observed symptoms, test results, user statements, and possible causes. Notes should also include any steps taken to gather data or verify early theories. This documentation allows other technicians to review the case or continue the process later without starting over. It also becomes a reference for future cases involving similar symptoms or systems. Collaboration is also important at this stage. Engaging with peers or team members often reveals new possibilities or confirms existing theories. Someone else may have seen the issue before or notice a detail that was overlooked. In help desk or IT support roles, working with others accelerates resolution and spreads institutional knowledge. Collective insight often leads to better diagnoses and more complete solutions. Several common mistakes occur during the early troubleshooting stages. Skipping initial observation or failing to ask detailed questions leads to weak or incomplete problem identification. Jumping immediately to rare causes like hardware failure without checking for basic issues wastes time and resources. Failing to verify user claims can also lead to the wrong diagnosis. These mistakes are preventable by sticking to the structured process and maintaining disciplined information gathering. Once a working theory is established, the next step is testing that theory in a controlled way. This means attempting to confirm or eliminate the suspected cause using diagnostic tools, substitution, or observation. If the theory is confirmed, the technician can proceed to implement a solution. If not, it's time to return to the identification and theory phase. The ITF Plus exam may present these steps as a flowchart, and understanding where you are in the process is key to selecting the correct answer. To summarize, troubleshooting begins by identifying the problem through careful observation, questioning, and data collection. The second step is forming a logical, evidence-based theory of probable cause. These two stages form the core of every successful troubleshooting effort. Whether you're repairing hardware, resolving a software error, or responding to a network outage. By following a structured, repeatable process, you lay the foundation for confident, consistent, and efficient technical support. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.